So now that we've talked about the main driver program and the parallel check your utils, check inner stream thread IDs method, let's go talk about the real workhorse stuff here. These are the methods that demonstrate the differences between flatMap and mapReduce concat and mapMulti when used with stream objects, stream instances that use reference types. So let's take a look here. Let's take a look first at test flatMap. So this is the one, of course, that should not run in parallel because of the weird limitations of flatMap. So let's see what we're going to do. We're first going to call a little helper method called generate outer stream, and we're going to give it the count of the number of iterations, which could be whatever you want it to be. The bigger the number, the more parallelism will demonstrate its value because of the n times q heuristic that we've talked about to show when you should use parallel streams. So we'll look at generate outer stream in just a second. It's going to generate a stream of objects, integer objects, that will run in parallel. And then we're going to call flatMap, and we're going to pass it this inner stream method reference, which, of course, just to not spoil the suspense, that will not run in parallel. And then we're going to check to see whether or not what happened here ran in parallel or sequentially. And of course, it's going to end up being sequential. And so all match will say that everything that came back here was sequential. So this will be sequential. And so then we'll print out that it ran sequentially, which it does. So let's take a quick look at generate outer stream. And this is actually used by all three of these implementations. So we'll just look at it one time. So generate outer stream takes an outer count, which could be 10, 1,000, 10,000, 100,000, whatever. And what it does is it generates a stream of ints from 1 to outer count, boxes them to turn them into integer objects. Now we're in reference type world. And then we convert this stream to a parallel stream, or at least we hope, well, we know this is going to run in parallel. So we have a parallel stream here. And then we're going to go ahead and print the outer thread ID if we're debugging, so we know what's happening, so we can see what's going on. So that's generate outer stream. So now we have a stream of integer objects that are all going to be generated in parallel. Here's flatMap. We know that that's going to make things run sequentially. Here's the inner stream implementation. So let's take a look at that. That's also shared by a couple of these things. So inner stream is going to get the outer thread ID, which is just the thread ID of whatever the thread is running in, that called inner stream. So we stash that away. We then make ourselves a new atomic integer called inner thread ID counter, and that's going to keep track of the number of integers that are processed by each thread. And now we make ourselves a thread map, which is a concurrent hash map, so it can be updated and so on concurrently without having to worry about race conditions. And then we make ourselves an int stream that goes from 1 to inner count. So inner count is whatever's being passed in. So let's say we're going to do 10. The outer stream has 10 items. The inner stream is going to be 1 item, then 2 items, then 3 items, then 4 items, and so on. So the inner count will be whatever the outer count is passing in. So we generate that many elements. We box them. We attempt to run things in parallel. For flatMap, this will not run in parallel. This is the annoying part. And then we're going to use map, and we're going to call check inner stream thread IDs. That was the method we just looked at earlier with the inner count, the inner thread ID counter, the thread map, and the outer thread ID. And that's going to come back with either S intermediate result, which we're just going to ignore, S sequential, or S parallel, depending on what it's determining. And so we're going to ignore all the intermediate results by filtering them away. So we only want to take S sequential result or S parallel result values and return that from this particular method. So that's basically what happens when we run this for the flatMap. And just for kicks, I have just made a few elements here. You can see we only have 10 items, and we're going to turn on debugging. So let's go ahead and run this, and we'll see what happens when we run it with the flatMap implementation. And this will show you what's kind of going on underneath the hood. This is pretty cool. So there's flatMap. So flatMap, as you can see here, is going to show you the outer thread ID for the 10 items. And if you take a quick look, you can see that these are the iterations. This is how many things we're going to be doing for the inner stream. And these are the thread IDs. and you can see that they're all different. So we have different thread IDs for all of these guys, because I have a 10 core processor. And then down here, you can see the inner thread IDs, and all the inner thread IDs only have a single item, and it always matches the outer thread ID. So you can see here, there are matches that are occurring here. So the inner thread IDs for the outer thread IDs basically indicate everything ran sequentially, and that's what it's saying there. And so as a result, if everything runs sequentially, then test flatMap ran sequentially. So let's now go and take a look at another implementation. We'll take a look next at test reduce concat, which I probably should call test map reduce concat for reasons that'll become clear in a second. So here, once again, we call generate outer stream, which generates this stream in parallel. And now this time, rather than using flatMap, we use map, but we also pass in the same inner stream method reference that we did for flatMap, except this time, as you'll see, it runs in parallel. But now notice what we have. Look here at the little hint. We have a stream of streams of integers, which we don't want. We want a stream of integers. So we reduce things with stream concat, and now we get an optional to a stream of integers. Then we use or else. We have a stream of integer, and then we take a look with all match, and we check to see, was everything sequential? And of course, the answer is no. And let's take a look and see how we know that. So if we come down here, here is test reduce concat. So once again, the outer thread IDs for the iteration that we're dealing with are all these values, and you can see that they're all unique again. And then inside here, you can see that the inner thread IDs are different. So the inner thread IDs have different threads than the outer thread IDs, indicating that they actually ran in a different thread, thank goodness, and that suggests parallel execution. I mean, it is parallel execution, and therefore the result comes back and it says ran in parallel. So that's good. Now we know that things are running in parallel. So let's go take a look at the next implementation, which is the mapMulti one, and this is really cool. This is the one I had done the earlier stuff in previous courses, but over the weekend I decided to get ambitious and see what I could do with mapMulti. So this is brand new stuff. So let's take a look and see. So you'll see here we come in, and once again we generate our outer stream, just like we did before. But now, rather than calling map followed by reduce, we're just going to call multi-map, and we're going to pass in a new method reference, because we have to do some other funky things, because the signatures are different. So let's take a look at this inner stream EX, which is a different version of inner stream. So the first thing you should note here is that inner stream EX takes 2 parameters. The other one took 1, which was just the inner count. This takes the inner count, which is how many iterations we want to do. And it's also passed in a consumer to an integer. And this is how it's going to be updating stuff into the output stream that comes back from mapMulti. So the first 3 things here are just what we had before. We have outer thread ID, inner thread ID counter, and thread map. That's just what we had before. But now we do something quite different and quite cool. So we're going to create an int stream here from 1 to inner count. We're going to run this thing in parallel, and it actually will run in parallel. So let's say run each computation in parallel, because it's not going to attempt, because it's going to work. And now we're going to use another nested mapMulti. And check this out. This is so cool. So this basically says for each int I, we're going to have this int consumer, and we're going to call check inner stream thread IDs, just like we had done earlier, except this time we get back a value, and we stash it away. And if that value is greater than S intermediate result, we're going to accept that value into the stream. So what that means is that every time this is called, it'll add another element that's going to be output to the stream. So at least we're going to have one. If there's something that's not the intermediate result, it's going to be put in here. So then we go ahead and sum these things together, and that ends up with the result from this int stream. And then we take that result and we accept that result into the consumer. So the consumer that's passed here at the top of this method is going to be set to the value, which is either going to be S intermediate result or S sequential result or as parallel result. That then gets accepted into the consumer, and that then will become the value that's propagated back to the caller, which, if you recall, is up here. So whatever comes out of here, it'll probably just be one item. It might be more than one, but I guess it'll be one for each of the different streams. So in that case, we're going to have a stream of these results, and then we're going to check to see if they all match the sequential result. And of course, as we'll see in a second, they do not match because it's running in parallel. So that's how we can figure this out. So let's go take a look now over here at the output. And here's the multi-map result. Once again, you can see that we have different thread IDs for the outer threads. And then you'll notice for the inner threads for mapMulti, there's some interesting results here, and they suggest parallel execution. So you can actually see what's happening here. We got parallel execution with different threads with different values. Some of them ran sequentially, but some of them ran in parallel, thereby assuring us that it is, in fact, doing parallel execution. And the other thing to note here is the larger the outer count, like this is just 10 values, so we could actually look at the output and make sense out of it. But if you have a lot of values, like 100,000, then you're going to get a lot more parallel execution. And the reason we know that is because when we look at the results here, actually, these are not the best results. If you look at the results for what I showed before, where we had done it with 100,000, then the mapMulti ones executed the best. Here, when we're doing this for a simple example with only 10 elements, it doesn't really matter. But as n gets larger, as the count gets larger, we start seeing a bigger win from using mapMulti.